How's everyone doing? I'm so excited to be here and so excited to follow that great talk, details about Node.js and the new features. I'm going to step back and take a higher level approach and start talking about how we could build like a full stack application today in 2022. And spoiler alert, it's going to talk about Fastify, GraphQL, and some really awesome stuff. So I was thinking about Kian, who gave the opening keynote, talking about people here up on the, who are in the audience, who are now up on the stage. So I came to NodeConf in 2017 and 2018 just as a guest, and here I am on the stage. So I was thinking about Kian when he said that. Thank you, Kian. I'm a developer relations engineer at NearForm, and also I teach a web development course at the local university where I live in France. So first thing I want to do is do an exercise with everybody here. I want you to close your eyes and imagine your next project. You got all the requirements from the stakeholders. You understand basically how long it's going to take. You're going to maybe work doing agile, or maybe you're just going to make a quick proof of concept and build on that. You got a general idea of what the project's going to look like. When I do this, I inevitably start thinking about all the new technologies and the new frameworks that I'm going to reach for to solve all those problems that I had in my last project. What I tell myself is, this time it's going to be different. This time it's going to be right. This time it's going to be rainbows. And this time it's going to be unicorns. And inevitably what happens though is I get like 80% of the way through my project and everything's going great, like development velocity is like so high, taking off like a jet airplane, and all of a sudden like something happens, like we hit this like brick wall. And this brick wall is generally like this last 20% of those non-functional requirements, those hard requirements. You already have code that's in production. You're trying to add things for security, authentication, authorization, all these things that weren't just like those functional requirements that were kind of like the easy part, right? It's that last hard 20%. So in our head, we're thinking rainbows and unicorns. In reality, we find ourselves somewhere like this, like down in the nitty-gritty, getting dirty, trying to fix things. There's production code. There's stakeholders that are calling. You're still like trying not to add too much tech debt into your project. So I feel like there's this massive gap between how we imagine our project and reality. Because we're just real-world people. We're devs trying to fix real-world problems. So what I want to do is think about that last 20%. And I use this percentage a lot, 80-20. And we call this the 80-20 rule. That came from this dude, Vilfredo Pareto. He's an Italian economist, and he had the Pareto principle. I know you can't read that quote yet. He said, maybe like 80% of our outcomes, just roughly 80% of them come from 20% of the requirements. If we're going to look at this like in a project perspective. So there's the whole Pareto principle. And I think Steve Jobs knew this because he left or got removed from Apple. He came back in 1996. They had something like 15 desktop models, cut them down to one. They had a whole bunch of portable devices. I think back in the day we called those laptops, cut them down to one. Peripherals, printers, just got rid of them all. Like he focused in on that hard 20%, like the core 20% of the project, or of the business in that case. So that's what I want to challenge us to do today when we try to build a tech stack, a modern tech stack today in 2022. Let's focus in on that hard 20%, and maybe, just maybe we could gain like 80% in our productivity if we take that into account from the start. So how can we build a tech stack today that's going to work for the real world if we focus in on that last 20% of those non-functional requirements that are going to be hard? To do that, I want to lay out some principles. And the first principle I'm going to look to when I build this tech stack is going to be modularity. And I'm talking about modularity in my tech stack. I want to be able to swap out layers in my tech stack if a technology is not working the way that I need it to work for my project. I think this is really important because sometimes those frameworks claim to do everything. And when they can't do everything, are you going to throw away like your whole project or like 80% of your tech stack? That's not going to work. So I want to see modularity in my tech stack. Next up on my principles is going to be developer experience. And I'm not just talking about modern APIs or your fancy pants CLI tool that's supposed to make your life a lot easier. I want to talk about code that can run anywhere, like in the cloud or on my dev machine, when I'm in the clouds, 30,000 feet above the air in an airplane where I don't have a good internet connection, or if I'm in a train where my internet's like in and out, or I'm in a hotel where like they say they have Wi-Fi. We're pretty lucky here. We have amazing Wi-Fi. So I want my code to run anywhere. For me, that's developer experience. I want to be able to run my end-to-end tests in an airplane without an internet connection. Next up on the principles, community. I want to see open source projects, 100% open source, community supported. When I have an issue, I want to be able to go and search like GitHub, find other issues, talk to people about this, get involved in the community, see if anyone else has had the same problem with me. I don't want to be relying on some sort of paid support package where after I call and talk to my account manager to get support. And you know, more eyes on the code, in theory, in general, it's going to be more secure, right? Like that's why we love open source projects. And like I said, 100% open source, not just 80% open source and 20% of the magic secret sauce run in some cloud service that we don't have access to. So my last principle is going to be transparency. And transparency can relate to open source, but I'm also thinking about transparency when we talk about abstraction layers. So we all know, we all love abstraction layers. That's what makes us productive as developers. But sometimes abstraction layers don't work for our use case, or for our requirements, or for our project. So I want to be able to peel back the layers of abstraction and be able to get my fingers down in the nitty-gritty, into the dirty parts of the code if I need to. Like abstraction layers shouldn't get in my way. They should make my life easier, but I should be able to move them aside if I need to. So now let's talk about the stack. And I think one of the traps that we fall into when we're designing a full stack project is we're going to start from the front and we're going to work our way to the back. So I want to turn that idea inside out, upside down. Let's start from the back and work our way forward to build this tech stack. So now I'm going to talk about the stack. You're going to see this picture of waffles a lot in my slides. It's like a stack, and they look kind of tasty, so you'll see them a lot. First up on the tech stack, we're starting all the way from the back. Hi, friends. Take note of my Twitter handle. You can flame me. Send me your hate mail. I'm strong. I can take it. But there's an elephant in the room. The elephant's name? PostgreSQL. Yep, I'm not talking about a fancy cloud-based database service. I'm talking about PostgreSQL. Why? Because it's the best relational database. I'm saying it right here on the stage. And I'm willing to bet in this audience, anyone who has a computer science degree or an software engineering degree, I'm willing to bet money, quote me on this, I'm willing to bet money that you've taken a relational database design course. So devs know it today, and they can build systems with it now. Like that's what's amazing about using a relational database is that you don't have to ramp up your whole team in some new technology. Like I said, it is the best relational database, but if you want to go like documents, you can do it, right? Like PostgreSQL has amazing JSON support, started like in version 9, and now we're up to like 14, or there's like the 15 release candidate, and each time like the JSON support gets better. You can do indexes, aggregations, you can do all kinds of amazing stuff in JSON. So if you want to work in like a document-based style, NoSQL style, PostgreSQL lets you do it. So it's your choice. It supports connection pooling. So if I'm building a modern full-stack application, I want to be able to scale. I want to be able to scale massively. And if we're scaling at huge amounts, every CPU cycle becomes important, right? And if our application, our server is trying to connect to the database with secure connections, there's a lot of overhead, like TLS handshaking, all this stuff. So if we can reuse connections, do that connection pooling, this can be like a huge difference in big applications that scale to huge size. Developer experience, it runs anywhere. I can spin up a Docker image of a PostgreSQL database on my machine here in like less than a second. So I can do that. I can run my tests in the airplane. I can populate my database, run end-to-end tests, easy. And again, love it or hate it. And it's a love-hate relationship for me. SQL is crazy powerful, right? We can do aggregations. We can do joins between different tables or collections if we want to talk about document-based storage. Like SQL lets you do it. So it's a love-hate relationship, but it is super powerful. Next up on the tech stack, we're here at NodeConf. We're building a web server backed by Postgre. We're going to be using Fastify. Mateo's out there somewhere. Fastify. If we're going to build a web server in 2022 with Node.js, it's going to be Fastify. I couldn't help but think about that cat munching on some of those tasty-looking waffles. It's inspired by Happy. It's going to be really familiar to Express devs. So if you've done other kinds of cloud functions or serverless functions, you're going to feel right at home. And inevitably, like your code base is going to evolve. Maybe you start with like a proof of concept, and maybe you're building a monolithic application today, but as like your project grows, complexity grows, Conway's law, eventually like your code base is going to resemble your organizational structure. And you know what? Fastify like evolves with you and your team and your project. You can split your code out into services or into plugins. You can isolate things. It supports that. Fastify, surprise, surprise, it's fast. It supports insane scaling. That's one of its superpowers. And of course, just like Postgre, it can run anywhere, locally, in the cloud, anywhere you want it to. And I mentioned real briefly that it does have a plugin architecture, and this is really programming Zen because you can isolate your plugins and decide like an API for ways for requests to access shared data that should be accessed from different plugins. So this is one of the amazing things about Fastify. And now, if we're building a web-based application, we have Fastify, we have Postgre, we need to have like an API server too, right? And I already gave away the spoiler. It's going to be GraphQL. And if we're doing Fastify and GraphQL on the server, we're going to be using Mercurius. And Mercurius is a plugin for Fastify that is a GraphQL server. And it's going to solve like real-world GraphQL challenges like right out of the box today. And when you like load it up in your application, if you run like the quick start, it comes with all those things built in. So I'm talking about caching. And Mercurius can do caching. It can hash your query string plus the variables to build like the key into a hash map, and it can cache things in memory. Or with like a plugin, you can connect it to a Redis database. And now you could have like a shared cache. If you have like a cluster of instances, they can use like a shared cache. So this can be really important when we're talking about scaling a big service in the cloud. And supports federation. So if you want to have like a GraphQL gateway, you want to maybe federate your schemas between different servers. That supports authentication, subscriptions, file uploads, all those things you didn't think about when you built like your proof of concept of your GraphQL server. Like it supports those things like out of the box. And we're going to talk about developer experience. Integrates the GraphQL developer console, so you can load that up in your browser. You can go and investigate your schema and your APIs and debug your queries. This is really great if you're like giving a GraphQL API to another team. They can just run it in debug mode, activate the GraphQL server, and they can start debugging and investigating the schema themselves. And lastly, it has the loader support built in, and we call this like the N+1 problem. But inevitably, your data is a graph, but we can also look at it like a hierarchy. You're going to have parents and children. And if you've ever written a GraphQL server, you write these functions called resolvers for each node in the graph. And the first time you do it, you're going to like fetch all the parents. And for each parent, you're going to run another query to get its child. And with the data loader support, you can aggregate all the IDs of the parents and then convert that into one giant SQL query, get all the children. So now you've gone down to 2 queries instead of N+1 queries for each parent. And you know what? If you're interested in some of that, just have a little plug, because at 2 p.m., we're going to do the GraphQL workshop. And one of the things we're going to talk about is the data loader support. So if you want to know more about that, be sure to come to the workshop this afternoon. Next up on the tech stack. So we are at NodeConf, talking about Node and servers, but I've talked a little bit about the front end too. And if we're doing GraphQL on the server, on the front end, in the client side, we're going to be using Urql. I call it Urql. Maybe you call it Urql. It's amazing. It's a GraphQL client, and it's going to be compatible with all the major front-end libs. I'm going to focus on React, but it's worked with other libs too, and it supports caching. Caching is amazing in Urql. It can do just like Mercurius, where you're going to hash the query and the values of the variables to build your key into the cache. It also has this plugin called the GraphCache, which actually normalizes your data. So if you have one query that gets a bunch of data, and if you configure the GraphCache correctly, it's capable of finding like entities in your data based on its type and its ID. So now you can have like 2 different queries accessing the same entity, and the cache is smart enough to say, oh, I already have that entity in the cache. I don't have to pull it from the server. If you do that, and you store like your cache in like IndexedDB inside your browser, all of a sudden you have like amazing offline support. So if you have a spotty internet connection, you want to build a web app that on portable devices that may not have constant access to the internet, like it supports that. You can build some really cool possibilities with that. If your connection gets lost, you still have data in the cache. You can actually write things into the cache and synchronize it back to the server once the connection comes back online. And it supports subscriptions, uploads, all those things that you're going to need eventually in a production app. It has this exchange architecture, which is what they call plugins. So this helps you, extend Urql the way that you need it to. And it's compatible with SSR. Developer experience. If we're talking about React, it has a hooks API. I'm going to show you that in just a second, which is just programming Zen. And they have a DevTools plugin for Chrome and probably the other browsers that lets you see your queries going by in real time and debug them and check the performance between your queries. So it has everything you need from one project out of the box. So I know we're at NodeConf, but I have to bore you with a little bit of React code. Here I'm going to build an application. We'll call this my pizzas application. And inevitably, I'm going to have like a page where we show all the pizzas. We're going to have a list of pizzas. If you click on one of those, you'll see the details. So here's my React component for that pizza list. There's actually one component. I split it into 2 code segments to fit on the screen. On the left-hand side, you have the query, the GraphQL query. I'm just querying all the pizzas, the pizza list. And on the right-hand side, we have our component, our React component. And on the second line, we have the use query hook. This comes from Urql. And you can get a result object. You can destructure that. And with that, if you have an error, you could do something. You could redirect the client somewhere else or display an error message. The fetching variable, if it's like taking a long time for your query to access the server because it wasn't in the cache, you could show a loading spinner or something else. And then finally, you could render out the data. So the API, this hooks API from Urql, is just really React compatible and React Zen. So that's the pizza list. Here's the pizza details. Only thing really different is the query. Because before I was getting all the pizzas. On the left-hand side of my query, I'm getting one pizza by ID. On the right-hand side, we have basically the same code, right? Use query hook, and I'm just showing a pizza details a little bit different. And what's going to happen if I've configured my GraphCache correctly with Urql and in Mercurius, you want to do that pizza list. Here I called it pizzas just to fit on the screen. It's going to work its way down the server, get the data out of the database. But on its way back, things are going to get stored in the cache. Now here's where the magic happens. When I want to click on one pizza and see the details, if I've configured my GraphCache correctly and Urql knows the entity for that pizza that I want to see details is already in the cache, it comes right out of the cache on the client side. No trips to the server. So this is like some amazing performance that we could get when we're building a GraphQL application here in 2022. So if we take that in mind, we have the GraphCache from Urql, and we write our GraphQL APIs to match our business domain. So we're thinking already about how the use cases of our APIs, and we're using a GraphCache. GraphCache is kind of like a global state, right? And maybe we don't need global state, and maybe we don't need Redux when we're writing React code. And that's how I feel. Every day I write React code, and I don't have to use Redux. Yeah. So we are at NodeConf, and I think I'm running a little bit short on time, so I'll speed up a little bit. But it wouldn't be right if I didn't mention React. That's the last part of the stack, because it's React. Like everybody's using it. Devs know it. You're going to be able to ramp up your team, scale up your team. You're going to need to learn a lot of new skills. That's why I love React. It's evolving, yet it's stable. Version 18, we had some surprises, but we've accepted those now. It's going to encourage you to split your code into components. And we can, with the hooks, we can now write all functional components because nobody really wants to use classes because, prototypes, JavaScript. Let's just write functional code. That's what we love about React has the dev tools. If you haven't written a React application, I know you have the dev tools installed in your browser. Vite, if you're not using Vite, just use it. So fast for packaging, bundling your code, works with ESM modules. Just use it. It's amazing. So I wouldn't be doing this talk justice if I didn't mention at least SSR. And if you're going to be using this tech stack with Fastify, React, and you want to do SSR, you should be using Fastify Vite. This came a project from a previous colleague of mine, Jonas Galvez. It's going to work with all the major front-end libs. I'm going to focus on React. It's going to handle page-level templating, right? Because eventually your page is broken into different parts. And usually I can integrate this with your React router on the client side. We need to do that on the server too when you're rendering things on the server side. So it gives you an API to do that. Also, it's going to integrate the client-side routing into the Fastify server. So normally define all your routes on the client in your React router. We need those routes in your Fastify server too, right? So when they navigate to some deep page that normally the client side would have handled that route, the server needs to handle that now too. So it gives you APIs to do that. And all the abstraction that it does, like it's just these APIs, they're really customizable. There's no magic. You can see all the code. If you're doing it with React or some of the other front-end libs, Jonas Galvez also made Fastify DX, which is like a turnkey solution for building an SSR app using Fastify and React and some other front-end libs. It's still in alpha, but if you're looking at doing SSR, you're interested in the stack, check that out. So, in the beginning, I was imagining rainbows and unicorns. That's probably not realistic, right? I think we use a good stack. We target that last hard 20%, the non-functional requirements. Maybe we can't handle them both, but maybe we could still have some unicorns. That's how I feel when I'm coding with a tech stack like this. So real quick to review, why do I love this stack? Because it's built for that last hard 20% right from the start. We're thinking of that right from the beginning. We want an app that's going to scale. It's going to have ways to have security built in. It's built for that complex functionality. The abstraction layers, they're there to help you, and they help you in that common use case, but you can peel them off when you need to. There's no magic behind the scenes. And it's highly customizable, right? It's a modular stack. I didn't present one framework that does it all. I presented a lot of different technologies to build a modern stack. And of course, all those projects are 100% open source, 100% community supported. That's why I love them. That's why we're here at NodeConf. That's why we love Node, because of those reasons. But now I need your help. We had the lean stack. We had the mean stack, the jam stack. What's my stack? Best I came up with was Frump, Fastify, React, Urql, Mercurius, Postgre. It's kind of awkward. Firm, that was awkward too. Still looking for a good name. Send me a tweet if you got a good name for my stack. I'm just having a hard time coming up with something that has a good ring to it. And of course, I wouldn't be doing this talk justice if I didn't mention I work at NearForm, and it's an amazing place to work. We get to contribute to open source. They're sponsors of some amazing projects, tons of downloads, over 1 billion monthly downloads on NPM. But we're also a professional services company, so we do consulting work. So we get to walk the walk and talk the talk at the same time, which is pretty unique because we're really involved in open source, but then we apply that to some really cool client work, building some really cool projects. And we're always hiring. So if you want to talk about that, hit me up. We got a booth too. Hit any of us up. We'll be really glad to talk about VC. Open source is art t-shirt. Thank you, NearForm. Ask us about it. Love to talk about it. I have to give a final plug in my last 20 seconds. GraphQL workshop is at 2 p.m. Looking forward to seeing a lot of folks there. Your life's going to be a lot easier if you have Docker Compose, and LTS Node version of Node installed before you come. If not, we're all going to be fighting for Wi-Fi. Actually, the Wi-Fi is really good here. But if you have time, make sure you have those things installed before you come to the workshop. That pizzas application, you can check it out at this GitHub repo, just like a proof of concept showing how that could work. And there's also links to these slides. So that's the end of my talk. Thank you so much. I don't know if we have, I guess I'm out of time. I don't know if we have time for questions or not. If not, send me a tweet or come see me anywhere and come to the GraphQL workshop. Thanks, everyone.